Hi, everybody. My name is Vannhi Huynh, and my Capstone project is in providing guidelines for wetlands assessment to support the payment for ecosystem services development in Vietnam. So a little information about where this location and this project took place. If you can see the map on the right side, it's located in southern Vietnam in Dong Thap region. This site is called Jamchung National Park. It is a pilot project for the Payment for Ecosystem Services project. This site is a Ramsar site, which is a wetland habitat that is claimed to be an international importance. It's in the Plains of Reeds in the Mekong Delta. It provides many ecosystem services to us, like carbon sequestration, cultural values, fisheries, and flood mitigation. It has high in biodiversity. It's also home to keystone species like the eastern source crane, which holds significant cultural values to Asian communities. A little bit background about myself is that I was born in Saigon, Vietnam, also known as Ho Chi Minh City. Growing up, I witnessed a lot of our valuable wetlands being destructed, from wetlands to new roads, hotels, shrimp farms, and rice paddies. And therefore, for my Capstone project, I wanted to come back to my country and give back to my community by doing this work. In addition to that, my family and I directly benefit from these wetlands, especially from this national park that I'm working on, Jamchung National Park. It's where we go for recreational activities and also for fishing as a food source. So before I start, I want to explain what ecosystem services is. So these services are the benefits that humans receive from the ecosystem. If you see the picture on the slide here are some examples of them, like flood mitigation, water quality improvement, food source, cultural values, a place for recreation and tourism, and much more. And from this slide and on, I will be referring to payment for ecosystem services as PES throughout the presentation. So what PES is, it's a system where beneficiaries like the government and industry pay communities to protect the ecosystem that provide valuable services. So an example on the picture here I put is that in the picture on the left top side, the upstream community, so the upstream ecosystem service providers, they protect the habitat and wetlands, which result in thriving ecosystem services. So increase in carbon capture, clean water, erosion reduction, going to the downstream users, the community there. So in exchange, the downstream users, like the city, would pay the providers with incentives like money to maintain these environmental benefits. So for example, in my national park case I'm working on, would be like tourism company would pay communities to protect the park, which in turn helps the park thrive and increase in tourism. So this project wouldn't happen without my amazing advisors. The first advisor that I worked with was Dr. Borja Riguero. He's a faculty and advisor at UC Santa Cruz. He's been extremely great in guiding me through a lot of technical processing and analysis. He also helped me look at the big picture of this project and for my future career goals working in a conservation field. And Dr. Jung Tu Ha, she's an advisor and researcher at the Research Institute for Forest Ecology and Environment, RIFI. She's been extremely helpful in explaining to me and bringing me to the policy side of Vietnam, helping me work with local community members and also local scientists there. This project was funded by the United Nations of Development Program, and also the team goal was to submit the technical guidelines to establish PES schemes all over Vietnam to UNDP and also the Vietnamese ministry. So why do we care about this? What's the issue? So the problem is that the Mekong Delta lost about 98% of our wetlands since 1816, so over 200 years ago. That's a significant number due to many reasons like anthropogenic activities. So specifically to Jamchung National Park, it would be the rice paddies, illegal activities, and the lack of funding. Although in Vietnam, we do have a successful payment for forest ecosystem services. It has been successfully improving local communities' livelihood and also decrease in the poverty rate in the area. However, there is no past initiatives for wetlands and marine ecosystems. Another problem is the limited funding. And by having past schemes, it can help with the limiting funding by creating a new source of income for the community. When I was in the field, I realized that speaking to park rangers there, they only get paid $150 a month. That's extremely low, even for Vietnam. And the average income for Vietnamese people would be $327 a month. that is way less than half of how much the park rangers make in a month, which is not sustainable at all. And therefore, it leads to them come and go often, leading to less management to the park. So you see the news article on the right side. Because of the lack of management, it leads to fire outbreaks from illegal activities and trespassing. What I'm further working on is fixing the limited data availability because there's limited monitoring capacity to protect and monitor these parks. So limited spatial data availability, it's a problem because it makes it harder to map and identify the ecosystem and their services. So therefore, why spatial data is important? Spatial data is important because it's essential in designing pest schemes. It's a way for the park staff to monitor their park over time and seasons. It's also a way for them to justify payments. So like how much carbon is stored in this area for the carbon crediting. My solution is to fix this problem is to provide high resolution data to the team, provide a protocol for monitoring and tools for the national park staff, and also a way to monitor changes over time in season. So you see the picture on the bottom here. What I found out during my searches was that in southern Vietnam, there's only two seasons, wet and dry. And you can tell that they change it significantly and very different. But a lot of literature that I read, it's only captured the park once a year, which is not a good way. It's not an accurate way to capture the park's dynamics. So overall, my mission is to build capacity for local staff to monitor wetlands and marine ecosystem using remote sensing, resulting in stronger and more sustainable pest schemes that protect the ecosystems while supporting community livelihoods. So how do I do this? What are my approaches and deliverables? So first step is I would need to acquire data from literature review, talking to national park staff for their existing data, collect field and remote sensing data. The next step would be for analysis, using remote sensing for pest and wetland monitoring. So performing a geospatial analysis on the area of interest, the national park. And my deliverables were a report on the park's health over times and season, and a user-friendly guideline on how to generate these results. So above from biomass, carbon stock, vegetation indices, and how to classify vegetation in that area. And all of these can be done in an automated workflow. So my solution to fix this problem is to have pests established for wetlands and marine ecosystems. So by providing a technical guideline. And through my research and conversation with national park staff, I noticed there are a few gaps, like lacking high resolution spatial data, and the local staff depended on outside team to generate these results and data for them. So therefore, I became involved by helping fill in this gap by creating a user-friendly monitoring guidelines to support in data collection. And this guideline will help this local staff generate data like the one you see on the right side. These are some examples of the park over the years and seasons. Having this data, it will allow the team to make informed decisions and track the progress of pest programs and conservation over time. And all these work are replicable and they can be done anywhere. So an example, what I've submitted to the national park will be an NDVI. So what an NDVI is a normalized difference vegetation index. So you look at the picture on the right side. A vegetation index is an indicator that assesses the health of the vegetation. So it ranges from -1 to 1. So the closer you are to -1 or 0 is a dead plant or an object, and the close to 1 means the plants are healthy. By giving this information to park staff, they can decide what area is essential to protect, conserve, or what area needs to restore. So my results was that I was able to attend a few consulting meetings and my work was presented. I received from the feedback from the team that it might be too technical for the staff. And at first I realized that I used two different programs to generate these results. I fixed it, I updated my user-friendly guideline, taught the staff on the guideline, taught the staff how to collect the data and step-by-step instruction with the codes along the side. And everything is done in one single program, which is a GIS program, a geospatial analysis program. And all this information are translated in Vietnamese. Here's an example of what the guideline looks like, a snippet of how you can get vegetation indices, above ground biomass, carbon stock, how to label different type of vegetation there. It's all translated in Vietnamese and also available in GitHub for others to look at. A big finding that I also found was that the difference in data quality. So on the left picture here, you can see the Japanese Aerospace Exploration Agency, JAXA. I have boxed in red that this park has mangrove forests. However, mangrove forests are hours away from this data. This is JAXA land use, and I created my own classification vegetation here. As you can tell, I tried to categorize the picture the same color as possible, and there are no mangroves in this area. The data from JAXA for this specific national park is wrong. And why the difference is that JAXA use a more broad vegetation. It's also nationwide for Vietnam's classification. What that means is that when you look at something more specific in the area, like a national park, it's not very helpful since they use more broad vegetation. So you see the legend on the left side, it would have deciduous forest, plantation forest, but it's not a specific vegetation what that is. So you see on the right side of the legend, I would have a different type of vegetation like Malilicular forest, different type of sedges, lotus, and more specific vegetation. And also the JAXA uses random forest classification. What that means is that they took samples of forests all over Vietnam to label this land use data for them. But the difference between JAXA and the data I collected and generated was that I used more specific vegetation. So by working with local community members and park rangers there, they only care about 6 different type of vegetations. So I used more specific for them. And I also sat down and personally validate these areas with them. So it's more accurate than JAXA. And also I use supervised classification, which is the method where I samples the forest in this forest, and the samples actually generate all this classification here, and it's specific to this park and this park only. And it's very important is that a lot of Vietnamese researcher uses NASA or JAXA to get their land use data. But if you're looking at something very specific like this national park, it's better to use this methodology instead. So my dream is to have PEST fully implemented nationwide in Vietnam. However, I did have some setbacks, such as funding cuts from the US presidential administration. This cut the project 3 months earlier, but I do hope this project get passed through by the Vietnamese industry and implemented in Vietnam. I would love for local staff to continue using these tools and to monitor park over time. In addition to that, it's very valuable from this project is Vietnam will be joining the carbon market in a few years and planning to reach net zero by 2050. And why that matters is that my partner organization advisor, Dr. Ha, will be leading this carbon market. And with the carbon data that I produce from the Cham Chim National Park, it will play a role in Vietnam reaching its sustainability goal. And with the extra time I had since the funding cut, I also joined the Blue Carbon Credit Assessment Team. In this team, we just try to find the best way to quantify blue carbon and establish proper crediting. This will be very helpful as Vietnam try to reach net zero in 2050 and joining the blue carbon market. So as a part of Blue Carbon Crediting team, I work with Dr. Heya from UC Berkeley and a lot of my fellow colleagues here at UC Santa Cruz in this blue carbon project. So what blue carbon is, blue carbons are carbon that's stored in coastal and marine ecosystems, such as mangroves, salt marshes, and seagrass meadows. And in this project, we are trying to find a way to evaluate blue carbon offset protocols for mangrove restoration projects. And what I'm specifically doing is analyzing allometric equations. What an allometric equation is an mathematical formulas that are used to estimate biomass. And then when we have the biomass value, we can convert it to a carbon value, and that's their carbon stock. And why I took charge in analyzing allometric equation is because it's a skill set that I learned during my past project. In order to generate the carbon stock from the national park I worked on in past, I had to use allometric equation and learn how to use these equations to get these numbers. Another thing that I discovered is that we want to limit overcrediting, and I discovered that a lot of these projects tend to overcredit up to 10% difference. And the whole goal of this project is to find the most accurate way to conservatively credit these blue carbon. And in addition to that, I'm also reviewing Southeast Asian project case studies because of my ecological background in that region. It allows me to evaluate them more critically and also contextually. Moving on to my personal goals, my next steps are to continue contributing to conservation efforts, help local community and help out my local community and bring science, policy, and local community members together to reach our common goal as protecting our environment in a more efficient way. I also became an avid bird watcher. Overall, Jim National Park is a bird national park. This project helps me appreciate their beauty and how they contribute to our valuable ecosystems. On a more positive news, last month, UNDP actually started hosting training workshops for developing technical guidelines to develop pests all over Vietnam. So we're in the progress of doing that. And it's also really great to be on the media. Being on the news about this pilot project brings more awareness on pests, also allowed people to understand why their backyard and our environment matters and why we need to protect it and conserve our wetlands. And with that, I would like to say cảm ơn or thank you for your time for listening. I would like to thank my advisors, Dr. Borja and Dr. Ha, for advising me through this Capstone project. I would like to thank you, the CSP program, and my cohort for helping me throughout this entire Capstone. And thank you to the Jamshid National Park and the members of the Vietnamese communities for welcoming me and collaborating with me in this amazing project. And lastly, I would like to thank you, the Center for Coastal Climate Resilience, for allowing me to support and for supporting me to follow my passion. And that's it. Thank you so much.